Hello and welcome to the lesson where we'll learn how to solve circuits using mesh current method. So first thing you want to do, you want to locate the loops. And loops look something like this, or this, or this is also a loop, this is a loop, and this is a loop, so I think you got the concept. So once you know where your loops are, you want to put a mesh current for that loop. So let's this loop have mesh current 1 and here be I2, so this is mesh current 2. And once you have these down, you want to put down the equation for mesh. And the way you do it is a lot like when you do it for Kirchhoff's voltage law, but it's not completely same, and we will see the difference here. So we assume that in this wire the current is I1, the mesh current is here, but when we come here the current is not I1, here the current is I1 minus I2, and that is by Kirchhoff's current law. So if I1 goes here and we have I2 here, what's left here is I1 minus I2. So when we get to writing equation for this resistor, we will show this in practice. So let's do that. We start with this resistor, so we have 2I1 minus 30 because current came here, and since we are entering the voltage source with the minus and leaving from plus, in the equation we put minus 30. And when the current comes here, we have this voltage source and the current is entering plus, so we write plus 20, and then we meet this one. But here we have the current, so plus 5 I1 minus I2, basically what I explained earlier, and this all is equal to 0. So it is a lot like the Kirchhoff's voltage law, and there's just a little difference. And now let's put down the equation. Actually, wait, it will be good if you simplify this, so let's do that. We have 2I1, basically this is the equation for mesh 1, but what you do, you will need this equation later, and it will be good if you simplify it in place, so that's what we are doing. If we add this, we will get minus 10, and we have, if we distribute this, we get 5I1 minus 5I2 is equal to 0. And we can simplify further by adding I1 with I1. So we get 7I1 minus 5I2, and we have minus 2 equals to 0. So if we add 10 to both sides, we will get something like this. So this is our equation for mesh 1. So we don't need this anymore. So this is our mesh 1 equation. Now let's put down equation for mesh 2. And how we do is pretty much the same way as we did in the first case, and this is basically always things happen like this, unless you have a current source in the middle, which we will consider later. But first let's solve this simple one where we have only voltage sources. So we put equation for mesh 2, and as I've explained, how did we put current here, no, voltage here in the previous is mesh 1. Now I want to simplify some steps when putting equation for meshes. And you should memorize this because it will save time when on exam or anywhere or you just want to solve. So what you do is add these two in advance. So because in later you will add anyways. No, this one. We did Z, so here. So we put 9 I2. Actually, I'll put down this equation now and then I will go the long way, so just to see that it works. So 9I2 minus 5I1, and all we have here is minus 20, so we can write it as equals 20. So let's see that this is correct. So how should we written was 5 I2 minus I1, because in this case we have the main current here, this, so this one is going against this one. So 5 I2 minus I1 minus 20 plus 4 I2, and if we distribute this, we'll get 5 I2 minus 5 I1 plus 4 I2 minus 20 or equals 20, and if we add these two, we will get 9 I2. So that's how you can take a shortcut, and instead of writing like this, you add these two in advance and then subtract the one with this, and that's what we did here. So it's a shortcut to writing an equation for mesh current with meshes. But of course you have to be very careful here, because you might make some mistake, but if you don't trust yourself you can go the long way. But either way, it is always possible to make a mistake. So anyway, we have these equations now. We have two equations and two unknowns. I1, I2, I1, I2, and two unknowns. So this is basically a simple inequality, simple two equations with two unknowns. So we can just solve it like this. You could either solve it with Cramer rule or matrix or just by substituting stuff. For example, in this case, I will substitute stuff, so we will get I1 from here is equal to 10 plus 5I2, this is this one, and this all divided by 7 because of this one. And we have this one down, and what we want to do, we want to substitute it here. And let's do that here. So I will expand here and bring this, wait, not exactly this, yep, like this, delete this one, and here we go. So we now have one equation with only one unknown, and we could solve it, but it would take time, and I think you know how to solve equations with one unknown, so let's not waste time, and I2 will be 5 amperes. I know this in advance because I've solved it already, so let's not waste time on equation with one unknown. So if I1 is 5 amperes, then with 0 should be 4 times 5 ampere. So let's put it down. 4 times 5 equals 20 volts. So that's makes it for one mesh method, but this is for a mesh for circuit where you don't have a current source. So with current source things are quite a little bit different. You get a super mesh here. So as I explained earlier, you won't want to put down like this I1, or let's be here I2, here I1 and here I3. And as you notice, in this case, since we have more squares or something like square, actually neither this is a perfect square, but basically you put down like this meshes, and now what you want to do is you put down equation for Supermesh. And how does that work? You write something like mesh 1, 3. Unlike when we had previously, why did I delete everything? When we had just one mesh 1, we put here mesh 1 and 3. And why it works is because we consider current to be like this. Instead of solving for just this, and actually you can't really do like that because you have 2 ampere here and you can't get the voltage by I2, I1, and hence that's why you do something like this. And I hope it is not very confusing. Basically, let's put down equation for this one and I hope it will make sense. So firstly, the current I1 enters the minus of this voltage source, so we had minus 60, then plus 10 I1 minus 10 I2, and then we continue like this, as if we never stopped. And we write equation for this mesh, but like this. Basically, you do everything as with the default mesh, but you consider mesh to be this one. And when you have something like this is a super mesh. So you call this mesh a super mesh. So this one is a super mesh. We could write here super mesh. Nothing, no violations. This is basically what it is. So let's continue. We reach, if you go like this, so we covered all these, so we are now here. Let's now add 2 I3, because mesh current now here is I3, and minus, we have also this one here, so minus 2 I2, and then we have I3 entering to plus of 20 voltage source, so we had 20 here, and this all is equal to 0. And now let's simplify this one as we did in previously. So minus 40 plus C sets with nothing, 10 I1 minus this goes with this, so 12 I2 plus 2 I3 equal to 0. We have then, let me copy paste. We have this is equal to 40 if we add 40 to both sides, and we can now divide both sides by 2, no, by 5, no, by 2, yes, by 2. So we divide both sides by 2 and we will get 5I1 minus 6 I2 plus I3, and that will equal to 20. So we don't need all this stuff anymore. So we have one equation down with 3 unknowns, but we are left with just one mesh. So what are we gonna do after? We'll show that. But first let's put down equation for mesh 2. And that's gonna be, these all gonna add up, so let's 10 plus 3 plus 2 plus 1, that's 16. 16i2 minus 2i3 minus 10i1 equals to 0, and we can divide both sides by 2 again, and we will get something like 8i2 minus 5i1 minus i3. Basically I swapped these, no problem there. And we have the second equation down, and as you can see we have 3 unknowns. So what we gonna do now? And what we're gonna do now is very simple. We will ask for help Kirchhoff. We put down equation for Kirchhoff's current law for this one, which we ignored all along. So what we have is I3 is entering and I2 is leaving. We have I3 and 2 ampere is also leaving, so we have I3 is equal to 2 plus I2, and we have now 3 equations with 3 unknowns. And the most important thing you should know is how to put these equations down. And once you have these down, then everything is about algebra. So I don't know, if you want you can try yourself and solve this. And this circuit was supposed to be solved for this I0, and we know that I0 is I2, so if you solve for I2 you will get the answer for this circuit. But for example, if you were asked to find the current through here, you would put down, since because of Kirchhoff's current law you have I2 entering and I3 leaving, so you would put down I2 minus I3 and you would find the current here. Or you could do for here, so basically if you would want any current from here you would put the Kirchhoff's current law. So the main thing with this method is to know how to put these equations. So once you have these down, then all is algebra and not much basically. Actually you might confuse, I don't know, I often make mistakes when solving stuff with, for example, 3 unknowns, very error phone, or I don't know. Calculators are good. So let's review everything we covered. So basically you need to find loops, assign meshes to loops like we did everywhere, and then you solve like with Kirchhoff's voltage law. But when you get here you will need to, for this you will need to put like 5 I1 minus I2, but if you're solving for mesh 2 and you're here, you would want to put something like 5 I2 minus I1. So that's one important point. And another important point is that if you have a current source between the meshes, you get the supermesh, and you should put down equation something like this. And if you didn't quite understand, you could rewatch the part where I was putting this down. So, you know, that's basically everything for this one. Okay, thanks for watching.